Hi, Honors Algebra 2. We are on Chapter 5, Day 2. We're talking about graphs of a quadratic function, and we're going to be using a table of values, so x, y table, so that we can graph a quadratic properly. So a couple definitions to get us started. A quadratic is a parabola, also known as a U-shape function. So either it will open up or it will open down, which then gives us the vertex. So this point right here is the vertex where the graph physically changes shape. It could either be the max point of your graph or the minimum point of your graph. So if I have a function, a quadratic like this, opening up, that vertex will be the minimum, the smallest value. Versus if I have my parabola that opens down, my topmost point will be the maximum vertex. We have also what's called an axis of symmetry, which is a vertical line through the vertex that creates a mirror image on either side. That should make sense because symmetry means both sides will be equal, like they're symmetric to each other. So if I can find a point on the left, I can find a point on the right just by looking at that axis of symmetry, that vertical line through the vertex. I know the suspense is killing us, so let's get going. Let's do some examples. So we're going to graph this function here given the information or equation. They tell me the vertex is 3, -1. So go to the right 3, down 1. It's this point right here. And it has a y-intercept of -6. Y-intercept means it's the point 0, -6. Right now it looks kind of like a line, but I need to realize this is going to be a quadratic. So this is pretty much one part of the parabola. Let's put down some information. The vertex point that we had, I'm going to change colors so that we really can see what every point is. This is the vertex 3, -1. I'm going to put that in the middle. A point that I found to the left of it is that y-intercept. And now I need to find a point on the right. You really could plug in any x value that's greater than 3. I'm going to be smart about it though because I want to find, I'll go to blue, the symmetric point. Let's make our lives easy. If you notice, there are 3 units in between the vertex and my y-intercept. So if I go 3 units to the right, I will have the symmetric point. I don't have to do any math whatsoever, and I know that this point would be on the graph because it's symmetric to my y-intercept, which is the point 6, -6. And I'm even going to label it. This is called the symmetric point. Normally, we're going to ask for 3 to 5 points, just like always, so put them in the XY table. And then we have our axis of symmetry right here that goes through the vertex, and it would be the equation x equals 3. So that is your graph. Now we'll do the same thing, but it's now given to us in what's called standard form. So we're not given information. We now need to find all this information. Looking back, you might have learned how to find this vertex. The formula for vertex, the x value is going to be -b over 2a. Highlight that, learn it, live it, love it. That is the formula we're going to use to find the x value of the vertex, and then we'll plug in to find the y. Quick reminder, this is your a value, b, c, just like if we did quadratic equation. So the vertex would be -4 over 2 times -1 in this case. So So the x value is 2. So for my vertex, x is 2. I need to find the corresponding y, which means just plug that x into the original equation. Instead of putting x, put the value that you found. I'm trying to find the y value when x is 2. So you get -4 plus 8 plus 5, you would get 9. That right there is my vertex point. You can even label it with a V. Oops. Okay, never mind. I'll label it right here, vertex. Let's graph that point. 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. And now I need to pick some more points. Pick a point to the right, a point to the left. Because I like to make my life easy, I think if I plug in 0 as an x value, that's a good option. If I plug in 0 to this equation, notice everything cancels and leaves the 5. So I have the point 0, 1, 2, 3, 4, 5 right here. Based on my axes of symmetry that goes straight through the vertex, I can find my other symmetric point. It would be right here. 2 units away, and it on the line y equals 5. So this is 1, 2, 3, 4, 5, and that's my symmetric point. I connect it in a nice U shape, nice symmetric U. That is with just 3 points. You might have to use 5 on a quiz, but just read directions. Now we're going to look at what's called the complete the square process. Complete the square. It's not as scary as some people make it. So let's take a deep breath and let's jump in. So we're going to use this to transform standard form, so this form, into vertex form. This is going to help us when we graph. Okay, we want to know where the vertex is, and then we can keep solving. Complete the square has a couple processes we have to go through, so let's do the first one to start. You want to move any constants to the other side, which means let's get rid of that 2, bring it to the left side. That is step 1. Step 2 is to complete the square. The formula for complete the square is going to be b divided by 2 squared. Learn it, live it, love it. For completing the square, that's the value that you're actually going to add to both sides. Well, let's see what we got in this case. Well, -6 is my b value. So -6 divided by 2 is -3. -3 squared is +9. Now I am underlining it because can you just add 9 to one side and think you're good to go? No. I'm going to move this over a little bit. You also need to add 9 to the other side. You have to have a balanced equation. You cannot just add something to one side and think that you're still balanced. Very, very, very important step right here. I'm going to do a little bit of cleanup. So this is y plus 7. Now, if we did this correctly, we should be able to get a term that can be squared. If I factored x squared minus 6x plus 9, I should be able to get a term squared. Well, I do. It's x minus 3. If you can't get to that, that means you completed the square incorrectly. It means the highlighted b divided by 2 squared was not correct. And then just like that, there you go. That's your vertex form. Right? Looking above, it looks just like right here. Y minus k equals a x minus h squared. Little information about it. our vertex is going to be, h comma k, which means the opposite of what's in the parenthesis for x minus 3 would be positive, and the opposite of the k value, which is negative 7. So I just followed the problem. It says transform the following from standard to vertex. Check. And state the vertex. Okay, next one. There's a little nuance with it because we wouldn't do the same example again. But I'll talk you through it. First step, like always, get rid of that constant. Normally at this step, I jumped to the b divided by 2 squared. Notice I was able to do that because this was a coefficient of positive 1. In this case, I have a negative 1 as my coefficient of x squared. I cannot complete the square yet until I factor out that negative 1. It's going to look like so. You have to have a coefficient of positive 1. Now I can do my completing the square. B divided by 2 squared. My b value is negative 4. Negative 4 divided by 2 is negative 2. Negative 2 squared is plus 4. Just like before, you can't just add 4 to one side and think you're good to go. You need to do the same operation to the left side. But watch out. Did I scare any of you? Hopefully I did. Okay. Did you really add a 4 to the right side? Well, not really. Look at my little dotted line here. I really, once you distribute, subtracted 4. On the right side, I added 4, but it had that negative 1 on the outside. So really, you subtracted 4, which means subtract 4 on this side. You have to do the same operation. Look at that negative 1 that it's being distributed. Okay, so we did our complete the square step. Let's check if we did it right. This becomes y minus 9. I know I did it right if I can get that term that's in parentheses factored to a term squared. Well, yeah, it can be x minus 2. And I am done. Okay, that is in my vertex form. Let's show what the vertex is. It's going to be the opposite of the negative 2, opposite of negative 9, and there's your vertex. In this case, the a value, if you look back up here, the a value is negative 1, and we'll talk more about what that's going to do soon. Last one, let's see how we do. This one looks a little crazy, but we'll take it step by step. First, move over the negative 11. Oh, one of those days. We have our negative 3x squared minus 24x. This coefficient in front of x squared is negative 3. I can't have that. I need to factor it out. You'll get x squared plus 8x. Let's do our complete the square step, which is b divided by 2 squared. So 8 is my b value, divided by 2 is 4. 4 squared is plus 16. Now, because I took out the negative 3 at the beginning, I have to remember that I didn't really add 16 to this right side. I really subtracted 48. Negative 3 times 16. On the right side, I actually subtracted 48. So what you do to one side, make sure you do to the other. This only occurs when you need to factor out your leading coefficient. Let's see if I did it right. I get y minus, that'd be 59, equals negative 3 times, let's see if I can factor that to get a term squared. It would be x plus 4. This is now vertex form. The vertex that comes out of here is negative 4, positive 59. And you just completed the square. Not too bad. Ask questions in class if you have them, but this highlighted formula is what will get you through completing the square. Good luck!